Here are your solutions to guided practice for section 4-5. A tiger in captivity is fed 3.5 pounds of food per day. The graph shows the pounds of food an elephant in captivity eats per day. Compare the functions by comparing their rates of change. So first of all, we would say that the tiger eats 13.5 pounds per day. That's the rate of change of the tiger. Now the elephant, we have to look at our data over here, and again we can do the change in y over change in x. And the change in y, our values go from 0 up to this point here, which we can read right here because it says that it's 125. So our change in y is 125 over our change in x is from this point here over to here, which is 1. So we have 1, and that is 125 pounds of food per day. So we can move over to here and say elephant is 125 pounds per day. So our rates of change are not even close. It asks us to compare by comparing the rates of change, and we would say that elephant, we'll just use an E, is much greater rate of change than tiger. Problem number 2. Carol's profit at a craft fair is represented by the function P equals 5B minus 15, where P is the profit, so this right here is profit, and B is the number of bracelets she sells. Kate's profit is shown in the table. So Carol is here and Kate is over here. First of all, it says compare the y-intercepts and the rate of change. So let's do it like this. Let's go Carol, and then down below we'll do Kate. So Carol, y-intercept is, look at Carol, we've got the y-intercept right here. The y-intercept is negative 15, so we'll make sure we see the negative there. And we will put the rate of change as slope here in a minute. So for Kate, we're going to move over here and we're going to look for the y-intercept. Again, we're going to notice that these are counting by 5, we're plus 5, and here we're counting by 1, so we're plus 1. We could move back 5, and that would put us to 0. Back 1 would put us to 0. So in this case, we would have a y-intercept of 0. And now our slopes. Our slope right here for Carol is right in our equation. It's the y equals mx. We're looking for m, so it's 5. And we can take a look at this back here and think about it. Its profit is the number of bracelets she sells. So we have $5 per, and I'm just going to put BR for bracelet, $5 per bracelet. This is the answer here. This was part of our calculating the addition here. And now for Kate, we're going to move over here, and again we're going to see the change in y is this side, so it's 5 over the change in x is over here, so it's 5 over 1, and again it's dollars per bracelet. So we have the same rate of change, $5 per bracelet, with a different y-intercept for Carol. Now the question is, how much will each girl make if she sells 30 bracelets? So the first thing that we can do is use our equation up here, and we'll calculate Carol on this side. So we have P equals 5 times our 30 bracelets minus 15. So 5 times 30 is 150 minus 15. 150 minus 10 would be 140, minus 5 more would be 135. So she's going to make $135, and again this side is Carol. Is our answer here, $135. On this side we're going to solve Kate. Now we could do one of two things. We could continue the table here all the way down to 30, which would be a tremendous amount of work, or we can recognize that we have an equation here. We have an output, which is dollars. Remember, this is x and y, or input and output. So our output is dollars equals our slope, which is 5, times our input, which is bracelets. And there is no intercept, but I'll just put plus 0 so we recognize that. That's one way we could do this, and now we can just take our 30 and plug it in right here. But another way we could look at we could recognize this as you should be able to see that we're just taking 1 and multiplying it times 5 to get this answer here. 2 times 5 gives us 10, and we can just go right down to our cell, which would be down here, way down here somewhere. We would have 30 times 5 would be 150, or again, put that value into our equation. 30 times 5, 150. Kate is going to make $150, and Carol makes $135. Problem number 3. The cost to rent a raft from 2 different companies is shown. We have Water's Edge rafts here, and we have Ryan's rafts here. Which company should you use if you rent the raft for 9 hours? So we have some calculating to do here, because 9 hours does not fit on this graph, and the cells don't go down to 9. So we need to take a look at some things. First thing that I would recognize is that we have a y-intercept of 0 on the Water's Edge. So we should be able to just take a look at this and find our slope. So we're going to go change in y over change in x. So the change in y from 6 up to 18 is 12. Change in y is 12 over the change in x from here, which is 1, over to here, which is 3. From 1 over to 3 is our run. So change in x is from 1 to 3, that's 2, so our slope is 6. So in other words, we're going to see that we're going to be charged $6 per hour. Recognize that that's in our table here. We have hours and we have dollars, so it's $6 per hour for Water's Edge. So let's put this out here. This is Water's Edge. Over here, we can look at this and see that every hour we're adding $2.25. Write it over here, $2.25, so that fits. Each of these cells is 225 different. And of course it's a rise of that. But recognize that that's going to point out that we have a y-intercept here. So if we back up $2.25, if we take $2 from 15, we'd have 13, subtract another 25 cents, and we should have $12.75. That becomes B. That's our y-intercept. So we're going to add $12.75, and our rate of change is $2.25. So we could go down to our cell for 9, and it's obviously going to be 9 times $2.25 plus $12.75. So we have 9 times $2.25 equals $20.25. And now we have to add our intercept, which is $12.75. We can add this. This is $1 plus the 12 would be 13 plus 20 would be $33 for Ryan's rafts. We'll write it right here so we see that that's $33. Now if we go to Water's Edge, this is much easier. We're using 9 hours and it's $6 per hour, so it's 6 times 9 is 54 for Water's Edge. We'll put it up here. 54 for Water's Edge, 33 for Ryan's rafts. Clearly you should rent from Ryan's rafts. Problem number 4, the essential question. What are the advantages and disadvantages to representing a function as an equation instead of a graph? Well, let's see what the book has to say about this. It is easy to see the rate of change for a function shown as an equation. In a graph, to find the rate of change, you have to determine the slope. A function shown as a graph displays the ordered pairs so you can easily see the relationship, but the relationship is not as easily shown in an equation. So basically what it amounts to is equations have advantages in some cases and graphs have advantages in some cases. It's a matter of what you're trying to see. So for example, if you had a graph like this and you have your line through here, if you're looking for any particular spot on the line, you can easily see the two values that are associated with that. But if you're looking simply for a rate of change, then you want to see something like y equals 3x. And immediately you can see that your rate of change, your slope, is 3. It shows up right there in the graph. Please do independent practice.